Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking about something I like calling completing the rectangle. This will be a little bit of a mix of some number theory stuff with some algebra stuff, little bit of geometry in the name and everything there too. So it's a good topic that kind of combines a few different subjects we can talk about here. Let's start with the kind of algebra portion and this idea of completing the square. All right, so completing the square is something a lot of people are pretty familiar with, I'm assuming. Right, so we have this equation here. We could have x squared plus 4x. And let me just move the 8 to the other side right away. So we have our equals 8 in this scenario. And the idea is we want to turn this left-hand side into something squared. So this whole portion over here, we want to have our kind of x squared plus 4x plus something that is going to factor as x plus something squared here. Right? It's pretty easy to see if we're going to start with an x squared, we need our x in that case. Now, if we know our formula for the kind of a plus b squared, or if you think about FOIL in this case, right, it's not too hard to see that we need that 4 divided by 2 as our plus 2 here. Because now we're going to have x plus 2 times x plus 2. So this gives us our x squared plus 4x plus 4. All right, so we actually need to add a plus 4 in this scenario. Now, of course, we can't just add a 4 to our equation, right? We can't just change our equation here. We need to balance that out by adding a 4 on the other side in this case. So, right, we can kind of look at this and we add our plus 4 on the right-hand side there as well. So this is kind of giving us, our kind of plus 4 here. So we actually get a 12 in this case. So we have x plus 2 squared is 12. And now this is pretty easy to solve from here, right? So x plus 2 is plus or minus square root of 12. And so simplifying this and kind of solving, we have x is negative 2 plus or minus. Remember, 12 is 3 times 4, so we can write this as 2 square root of 3 in this case. Now, a little bit about the name off to the side here quick. Right, so the idea here, going back to our original expression, is we have this x squared plus 4x minus 8. And if we think about this geometrically, what we end up with here is we're going to get our square, right? So we have our square with a side length of x plus 2, right? So we have our x plus 2 and x plus 2. And then don't forget then we kind of have this minus 12 in this case. So our picture is we have some number where things are off by, right? So we kind of have this minus 12 here, but then with this, our square plus negative 12, right? Our square minus 12 will give us that x squared plus 4x minus 8. And what we're going to do next is draw a similar picture with kind of a rectangle. And so this is where the name then completing the rectangle kind of gives us the idea of more factoring tricks. Now let's look at an example here. So we want to complete the rectangle for the expression xy plus 4x minus 3y minus 5. Now, if you've heard of some of these tricks before, you might know this as SFFT, and that's kind of another way here. But right, thinking about this as synonymous with completing the square, this is why I kind of really prefer this idea of, okay, we're completing the rectangle in this case. So I want to kind of write it out in a similar way. We don't have an equation here, but I still want to think about this as, right, xy plus 4x minus 3y, and then a plus blank or a minus blank or something there. And then we have our minus 5 in this case. So we leave room here for something to complete the rectangle, aka complete this so it factors. And then we're going to have to make sure we don't actually change our equation in the process at the end. Now, picture is the same here. This is now 4 terms. We have x and y, so we need to be a little bit careful with our factoring. But we're now going to have x something, y something in this case. Now, if we think about FOIL here, right, what does x times this give us? What does x times the outside term give us? Well, this is going to be something involving the 4x in this case. Meaning we have to have here then a plus 4. So we need to have y plus 4 as our kind of second term in this case. Right? That's what we're going to get here for our expression. What if we continue our FOIL and do the inside terms, right? So this is going to be y times something, and that should give us a negative 3y in this case. Now, what we have here then is our minus 3 in this case. So here we have x minus 3, y plus 4. This will, of course, give us a constant term here of negative, right, 12. So we're going to have a negative 12 in this case. Can we just subtract 12 from our expression? No. So we need to add 12 at the end so we don't actually change our situation. So the idea here then is that we have a plus 7 in this case, right? 12 minus 5 is giving us a kind of plus 7 in this scenario there. And so now kind of going back to this full picture, what's kind of happening here again, right? This area, or if we think of this as now kind of a geometric area or something, we can think of that again as a rectangle. So we have our kind of rectangle now. This rectangle is going to be x minus 3 by y plus 4. And as long as we kind of want to make this match our original thing, we need to add 7. Because then that expression down here will be equal to the expression above. The area of this rectangle plus 7 gives us xy plus 4x minus 3y minus 5 in this case. So this is this idea of completing the rectangle here. So we're saying xy plus 4x minus 3y minus 5 is equal to the quantity x minus 3 times y plus 4 plus 7 in this case. Now, this has been kind of purely algebra so far. So what if we try to look at this in our kind of example, our big example of the day is going to be doing this to solve an equation from here. So just starting where we left off, let's not forget all of the work we just did on the previous page. All right, so just to remind us here, we completed the rectangle. Our first step here was to complete the rectangle and say we have x minus 3 times y plus 4. And then that was a minus 12, so actually to get to negative 5, we have plus 7. And this whole expression is supposed to be equal to 0 in this case. Now, algebraically, we have 2 variables and 1 equation. It shouldn't be too hard to figure out. You could solve this for x in terms of y or y in terms of x. If I give you any x value, like if I tell you x is 2.3, you can find a y value that will work. And so the important thing here is that we know we have x and y that are required to be integers. This is where the number theory stuff comes in. We're going to see in a second how we can now think about factors, prime numbers, and how that's actually going to allow us to figure out what x and y are here. So we have x minus 3, just rearranging this a little bit, y plus 4. These two numbers added together multiplied together. Note they're still integers. If x and y is an integer, so is x minus 3. So is y plus 4. And this is supposed to equal to negative 7. So this is actually negative the prime number, a prime number in this case. So the only factors of this number, here's where we start to see things working out nicely. The only factors of this number are 1 and 7, but remember these things could be positive or negative. So in one scenario here we could have x minus 3 is 7, x minus 3 could be 1, x minus 3 could be negative 1, or x minus 3 could be negative 7 in this case. So right, we have 4 possibilities for x in this scenario. We have our kind of 4 values for x, and then we can go from there. Now, notice that if we know the x values here, the y values are determined as well. Right, so if we look at the y values then from here, well, if x minus 3 is 7, what times 7 gives us negative 7? This has to be negative 1 here. Likewise, negative 7 here. Then we have, right, positive 7, and then we have positive 1 as our last one. So we have 1, right, then we have negative 7 here. Let me just kind of make it clear that that's a negative 7, and then we have our 2 answers, negative 1, 7, negative 7, 1 in this case as well. So this gives us here our situations for not x and y, but these are x minus 3 and y plus 4 in this case. So if we take these kind of one line at a time, right, we have these 4 possibilities for x minus 3 and y plus 4 in this case. And now we want to start combining these into our kind of final solutions, our final answers, and stuff like that in this case there. All right, so these are the kind of possibilities we're looking for and what we kind of have in this case there. So looking at them one at a time, if x minus 3 is 7, then this tells us that x is 10. If y plus 4 is negative 1, right, subtracting 4, we get y is negative 5 in this case. So this is one solution we have here. Is it the only solution? No, because we can keep doing this, right? If x minus 3 is 1, we are going to get then that x is equal to 4. So we're adding 3 to the x there. Subtracting 4 from the y, we get y equals negative 11 in that case. In the third case, we have x is equal to 2. Subtracting 4 from 7, we get y is equal to 3. And then our final case, we actually have a negative value for x. We have x is negative 4. And then subtracting from the y, we get y equals negative 3 in this case. So at the end, it really was our number theory that allowed us to solve this and come up with the equations, right? And come up with the integer solutions. So we end up with 4 solutions, 4 pairs of x, y that satisfy this equation. If 7 wasn't a prime number, this would still work, but we would have more possibilities, right? If instead of 7 we had 8, we would have, right, 8 and 1 or 2 and 4, things like that. So there would be a lot more possibilities for x and y, but the idea and our strategy would be exactly the same. So that is this idea of completing the rectangle, and typically this is mostly used for kind of number theory questions where you want integer solutions. Remember, we had a previous video on Diophantine equations that was all about that there. So that's where we can kind of solve these with completing the rectangle as well. Hope you guys enjoyed this video. Check back each Thursday for a new math tidbit this year. Right? If you like this, please hit the like button. Please subscribe. Really helps out. And check out our ZIML site at ziml.areteem.org for more practice and ways to improve your math and problem solving abilities. Goodbye.